Hello and welcome to our PRISM CoCoRaHS Climate Portal instructional webinar. We're glad to have you with us today for a look at a new tool exclusively for CoCoRaHS participants. This will help us connect our daily precipitation measurements, weather, to seasonal patterns, long-term averages, and year-to-year variations, thus climate. Today we'll give you a short tutorial on the PRISM Portal. That's what we're calling it for short, and we'll cover the following. We'll start out with a short introduction explaining the background of the portal, introducing our collaborative partner PRISM, who developed the portal, and briefly explore the world of precipitation estimates, normals, and model data. From there we'll move on to how to access the portal and use its functions such as the mapping system. Next we'll explore some applications of the PRISM portal, such as average estimated precipitation for any location in the United States, historical time series for monthly and annual precipitation, and how PRISM normals are used in CoCoRaHS water year summaries. Finally, we'll end our webinar with looking at several frequently asked questions about the PRISM portal.
Henry, I'm really excited about this. 35 years as a climatologist, this tool is going to be one of the neatest ones for the general public as well as scientists to put our local rainfall observations that we can each take in our own yards and put it in perspective with our long-term climate. So let's take it away.
Yeah, this is really exciting to see what has been developed here. Well, the CoCoRaHS PRISM Climate Portal, we call it the PRISM Portal for short, as I mentioned. CoCoRaHS has teamed up with PRISM to create this exclusive feature for CoCoRaHS participants. So this is not for everyone, but if you're a CoCoRaHS participant, you will have access to this. Again, as we mentioned earlier, this tool developed at Oregon State University. We look at it helps us to take our weather data and look at it in the climate in terms of climate. The portal again is here for exclusivity for CoCoRaHS volunteers, and we've got a PRISM Portal page, web page that's being developed, and you can find out more about what's going on from there. Let's, well, Nolan, what do we know about PRISM? What's the story with PRISM?
Okay, so we've been talking about PRISM. What do those letters mean? PRISM stands for Parameter Elevation Regressions on Independent Slopes Model. Basically, it's a model that was developed first with the Rocky Mountain and Pacific Northwest in mind, where weather stations may be far apart, but precipitation varied greatly, with topography being the main driver. Chris Daly at Oregon State University began working on this more than 20 years ago, and since then PRISM mapping has become sort of a standard for high-resolution mapping, especially in complex terrain, but really for any part of the country where you have climate data and you have topographic information. Put the two together and out comes maps. This is what we call PRISM, and we're just delighted we've been able to team up with Chris and the PRISM Climate Group there at Oregon State.
Well, what can you tell us about some of the products that they have, Nolan?
Well, and I've been looking at PRISM maps ever since they first rolled out their first set, again, something like 20 years ago. Just earlier in 2012, one of their most popular maps ever, the new Plant Hardiness Zone map, and I don't know how many millions of people have hit that website already to look at their plant zones, but also just maps of average precipitation, now maps of individual daily and short duration precipitation, maps for extreme precipitation being used by civil engineers and stormwater and floodplain managers. PRISM has put out thousands of maps now, and so what we're seeing for CoCoRaHS is just a small part of what PRISM is doing for climate applications across the country, and in fact in some areas across the world.
So PRISM does something called PRISM Estimates. Can you tell us a little bit about that?
Yeah, well, when you see a map that shows continuous data, color coding, the assumption is that, wow, you must have data at every one of those points. Well, the answer is no. There's only weather data stations at depending on the variable, maybe one per county, maybe not even that many. And when it comes to precipitation mapping, we have historically mostly the National Weather Service to thank, but stations perhaps one every 25 miles or so across the country. And what the PRISM model does is it takes the available data, develops relationships, again, with elevation, with topography, with proximity to coastal areas, etc., and develops a best guess estimate, very similar to what a climatologist like myself, who used to draw many, many maps by hand, sort of the thought process that we would go through, but now it's been fully automated. And so it's not actual data at each of those points, it's modeled, which means it's an estimate from the available data.
How about historical normals?
Well, again, in the world of climatology, normals are something we've talked about for seemingly forever. Starting something like 100 years ago, climatologists settled in on a 30-year average, updated every decade. And the first ones of those in the country were done, as I recall, back around 1920. And every 10 years since then, we've updated these 30-year averages, and we call those our climate normals. And that 30-year base period is long enough to sort of smooth over the ups and downs, the climate variability that's a natural part of our climate. And right now, we've just recently moved to the latest 30-year period, which is now 1981 to 2010. And there's an example right there where you see what the actual year-by-year data have looked for this particular location for 30 years, and then the average will be based on those 30 years of ups and downs. But that becomes our new 30-year normal, and that's the base period that's used in this PRISM portal.
And many of our CoCoRaHS volunteers and participants out there would probably want to know, was the CoCoRaHS data used in the normals?
Well, for most of the country, the answer is no, because CoCoRaHS has only been active for a few years, especially east of Colorado. And what the rules that PRISM has used in the development of their latest 30-year normals is they need at least 10 years of data from any individual station to contribute to the estimates of the 30-year period. And out on the plains, 10 years is used. However, as you get into the Rocky Mountain region, where precipitation varies so much, then 5 years is sufficient to provide some useful information towards a better long-term estimate. And it turns out that 723 CoCoRaHS stations, mostly in the Colorado, Wyoming, New Mexico area, qualified, and 236 actually had full 12-month data. So CoCoRaHS is contributing to these normals in a small area, Colorado and immediate surroundings. For most of the Colorado, or most of the country, it's going to take another 10 years before CoCoRaHS data are included over the country as a whole.
And does the PRISM portal, is that all 50 states? Canada? What's the scoop here?
There's bad news here for our friends in Alaska, Hawaii, and Canada. The PRISM normals have only been done for the lower 48 at this point. So the products that we're going to be showing today are good for the 48 contiguous U.S. states, but sorry, Alaska, Hawaii, and Canada at this time.
Thanks, Nolan. Well, let me talk about how to access and use the PRISM portal. Well, this is the second part of our talk here, and let's basically talk about how to get started here. So make sure you're logged into your CoCoRaHS account when you do get on the web at our website, onto our homepage there, and then click on My Account. You see where the arrow's pointing. Let me get my mouse over there. There we go. Right there on My Account. Click there, and that will bring you up to your account page. And here on the account page, you'll see the third section down is called PRISM Portal. And you have two options on here. One is to click on the part that says PRISM Portal, the blue words, and that'll get you access to the whole continental United States, and then you'll have a map to choose from there. Or if you go to My Station down at the bottom, there's a little section called PRISM Data, the blue words there. Click on that, and that will get you access to your specific station's PRISM data. So that is more for more specific. Once you're there, it'll bring you to this page here, and now you're in the PRISM Portal. And you'll have four button options here to choose from. One is the state and county. The other one is by station number, coordinates, or by clicking on the map. We're going to show you examples on each of those. And the first one would be your state and county. So here we're using Plymouth, Massachusetts today. You would click on state and county and go right to the center of a county. And there we go, right in the middle of Plymouth, just west of downtown Plymouth. Then you would click here on View Precipitation Data, and we'll show you shortly what that'll bring up. The next one is by station, to go to your CoCoRaHS or any CoCoRaHS station location out there, and you'll go right here, use the pull-down menu, choose your station. We're using one here right near Herring Pond in Plymouth County, and you click on View Precipitation Data, and that'll take you there. Third option is to use the longitude, latitude, and you would click on that button there, and bingo, it'll take you right to the spot, and click to get to the data. And the fourth one is to choose a location on the map. So anywhere you wish on the map, click in the box. It doesn't have to be at a station, and that'll take you to that location. And again, when you hit the View Precipitation Data box there, you'll get this, and this is a historic normals for that location, and we'll go into a little more detail on that here shortly on what that shows. One thing you might want to just take a look at here is how do I move back and forth. And if you go to the upper left corner of the PRISM Portal, you'll see these underlined sections. There are little breadcrumbs that are left. You just take your mouse and click over those, and it'll take you back and forth to where you want to go. Well, the PRISM Portal, handling mountainous terrain. Nolan, would you like to say a few things on that?
Well, yeah, and I want to tell you that little graph may not seem like anything, but there before your very eyes is a best estimate for the point that you selected of the 30-year average precipitation, 1981 through 2010. And easy to take that for granted, but in order to accomplish that estimate, lots of things have happened in the past, including many years of data collection, especially from the National Weather Service Cooperative Observer Network. So if you'll see there on above the graph a little box that says nearby range, if you click that, in addition to getting the line that shows a line graph of the monthly average precipitation, you now have a shaded area, and that will give you an idea of how the precipitation average may vary in the immediate vicinity of the point that you selected. Now, when you're out in the Great Plains of the U.S. or the Midwest, there's not going to be a lot of variation over a short distance from the point you select. But when you're in coastal areas, in the vicinity of the Great Lakes, and particularly in the Rocky Mountain West, precipitation can vary a lot over very short distances. So that shading is giving you an idea of the range in precipitation within about a half to a mile of the location that you're clicking.
Well, thanks, Nolan. Let's take a look at some applications. How can we use the portal? How can we apply this to different situations? One of them is to find out the average estimated precip for any location in the United States. So you pull up your map and click on the map there and choose a spot. It doesn't have to be a station number. It can be any place. Here's one for Ontonagon up on the UP of Michigan, the other one here in central Illinois. But just simply choose that spot wherever you want to take a look at. And here's an example. What kind of application? Well, you know, we're getting ready to go on vacation this July. We're headed to Santa Cruz, California. And as we start to pack our suitcase, should we put that umbrella in there? Well, this is a good tool for that. So go right over and we click on the location on the map where we're heading, and you can zoom in and out on the map by using this tool right here. So click right there, and then we go to the magic button, View Precipitation Data. I push the button, and voila! Wow, it looks pretty dry for the past 30-year averages here in June, July, and August in this part of Central California. So therefore, you can leave the umbrella at home. It probably would be the one year I did that, and it did rain. But anyway, this is a great way of using this. Nolan, do you want to say anything about that?
Well, just every single point in the lower 48 you can do this for, from the south tip of Florida to the north tip of Maine to the mountaintops in the Rockies. This tool is an educational opportunity to study the climate of our country, and you can do it really fast and easy with this PRISM portal.
It's a great tool. Another one is a historical time series. So for any given location, take a look at several things. We're going to look at three different options here. And how does the monthly precipitation vary over the past 15 years, so for a period in a certain location? Then how does the July precipitation vary there, 1 month, and then the annual precipitation from a longer period. We can go all the way back to 1895 with this series. So let's go to the first one, and we click on here, how does the monthly precip vary in Plymouth, Massachusetts over the past 20 years? And also, let's just make a note there. Nolan, you want to tell us about the likely to change piece?
Yeah, these model data, new data keep coming in to the model. And for years past, there's very little change going on. But for the last few weeks to the last few months, new data keep coming in, and they keep rerunning calculations. And so your last, particularly the most recent month, back a few months, those numbers could change as more nearby data come in. So just want you to be aware that if you see it change from one time to the next time, there's a good reason for that.
And so what you do is you select this one, click on there, and then click in the bottom right, plot the time series, and bingo, there you go. It plots the series, and let's take a look even closer at that. So we'll look at the graph a little further. And so there's a mouse over function. So as you move your mouse back and forth, and here's an example right here, it'll give you this box for that point along the graph. And this is April 2007 at this location. The precip that year was 7.79, and the average 30-year is 4.46, and you can see that's above the average right there. Blue line giving you the 30-year average of precip, and then the green is the actual precipitation. Next example, here's one here. Select a month. So the first one was a time span. The second one is just for 1 month only for each year. And so here we're looking at the month of July. Okay. So from 1961 to 2012, what's it look like each July? So we click on the button in the corner, and there it is. And again, it provides that graph, and we can look at each July, and we'll get a little closer. Again, moving your mouse over a certain area, and by putting the mouse right here, we see that in 1980, 1.53 inches, which was below the 30-year normal for that time. Up in the top right corner, you can also see you can turn off and on the boxes. The nearby range was that what Nolan talked about earlier. And it's a little part on here you can see a little bit, that's the green shading. You can turn that on and off. And so that's that example for the month. And then the last one here for the time series, the annual value. So how does the annual precipitation in Plymouth, Massachusetts vary from 1895 to 2011? And so there's a button to push again. Set your year. You can move these back and forth. Click the time plot series, push the button, there it is, it graphs it for you again, and here we go with the mouse over, and you can see from 1895 to 2011, pretty much back and forth there, and there's the 30-year normal in blue Here's a very rainy year in 1972. I think that was probably Hurricane Agnes or one of them in that area, 67.03 inches.
So you right away get a climate forget it.
Okay, there we go. So let's go to the next slide, and so there's also a button on here where you can click. It says view or download the data values. So you can do this for any of these time series, and it takes it and it exports it into table form using in Excel, and there you go. Follow the arrow there, and I just used a portion of this, but there's your year and the amount, and then from there you can use the features in your program and make your own custom graphs, and very valuable for extracting the data. A lot of stuff you can do with this. Okay, other applications. Well, here's one, and I'll let Nolan talk a little bit about this. The PRISM normals used in the CoCoRaHS water year summaries.
And as we roll out our 2012 water year summaries covering the October of 2011 through September 2012, this will be the first time that we superimpose on these on our recent year's data for every single station in the country in the lower 48. We now can put a best guess estimate of, or best modeled estimate of average precipitation to go along, so we can see how our actual observations from 2012 water year compare with the long-term averages. And then that graph on the right will show the day-by-day accumulation of precipitation through the year and how that compares with the long-term average for the vicinity. And then the example shown below, which is right here in our hometown of Fort Collins, how we were off to a good start with good fall precipitation. Then it went dry in the late winter and spring, and we never caught up, although we did have a good storm there in early July. So these are the kind of
amazing tool.
This is just a great tool. We hope everybody.
And this is available for everybody. Everybody that's a volunteer or a participant can look at their station and do this. And wow.
And we want you to take a look at the data and how these new modeled estimates compare with your local experience. This is the best thing since sliced bread, in my humble opinion.
How about showing us, talking about this slide, Nolan, for the comparison?
Well, there's your water year summary in table form. Now, right beside your monthly totals for the water year of 2012, you'll have the 30-year average estimated by the PRISM model. So you'll be able to see each month, were we above, were we below, how close were we, and then we'll do this each year going forward. So we'll have that reference point.
Well, we come to a part in our program here, frequently asked questions. And there's a lot of questions out there. We've got a couple of them here for you. And I'll ask the question, and Nolan will attempt to answer it. So, yeah, number one.
What is model data, you ask? And we sort of touched on that earlier, but again, it's not actual observations. We didn't have data points at every location in the country, but the PRISM model, the folks at Oregon State developed this model that used the best available techniques to create an estimate for each pixel, each one roughly 1/2 mile by 1/2 mile, so that we have a continuous field of estimates for the whole country, for each month, for each year, and then for the 30-year average. And these data are then an available data resource that anyone can use. And already, as Chris Daly and his crew there know, there are many, many organizations grabbing and utilizing the data for any of a number of reasons, anywhere from where's the best place to be marketing snowblowers to questions about agriculture, production, gardening, even ecological questions, endangered species, habitats, etc. An amazing amount of utility of a product like this.
I like that one, when it's time to sell ice cream. It's right up my alley. Okay, well, here's the next question. Why does the PRISM time series look different from what I'm collecting with CoCoRaHS?
Well, we wouldn't be doing CoCoRaHS if precipitation wasn't so incredibly variable. Again, the data points that went into this model, relatively few, relatively far between. The estimates of 30-year normals we feel will be very, very good, but there's going to be a lot of variability, especially for individual months. You know how it can vary across the street, across town, across your county. It's going to look different because the estimate will be based on data that may have been some distance away from your station. The more CoCoRaHS people participate as we move forward, the more the future estimates will begin to look more closely like your own, and it's because your own data will be used to make these estimates.
Well, here's a great question. Probably on a lot of people's minds, do you still need my CoCoRaHS data? Should I still be doing this?
And that's one reason we had a little fear and trepidation about releasing this incredible new product, because people will say, well, they're already making a graph for my location. Do they even need me? And the answer is that data point, those estimates, are only as good as the data and the model that they're based on. And until we have more nearby data like your own, these estimates will always have quite a bit of variability and occasionally some significant error in them. So, and especially in the summer, thunderstorm precipitation, 4 inches here, nothing there. Unless we have your data, we will never get those patterns right. So thank you. We still need you every bit as much as we did before.
And here's our last question. Does PRISM use weather radar?
And we all, or most of us, have come to rely on weather radar to get a up-to-the-minute picture of how storms are moving across, and then you can click on that hourly or daily rainfall totals. Until recently, radar has not been integrated in products like these PRISM maps and estimates. And here in the western U.S., even today, radar is helpful but very, very incomplete in filling in the picture. The mountains can block the radar. Snow is often very difficult to capture and detect on radar. But what PRISM is doing, going back to about 2002 and now moving forward, they are going to be integrating where they are able to radar into their estimates to enhance the quality of the monthly and eventually the daily products that will be produced in the future. So radar integration is coming. Thank you.
Well, thank you so much for joining us today in exploring this great new product we're excited about. And if you have any additional questions, here's a email address down there, info@CoCoRaHS.org. Very easy to remember. I'll get back to you very quickly on that. But we're excited. And Nolan, thanks for partnering with me today as we talked about this. And wow,
so,
this is exciting.
Yeah, this is great. And all of you, please give it a try. See what you think. There's some chance you may find some things that don't look quite right, look a little fishy. There is the potential that there could be an error or two in the system. Please let us know if you spot something that doesn't look right. It can only help make a better product for the long term.
Well, thanks, folks. Thanks again for joining us, and we ask you to give it a try. Thanks. Take care now. Bye.
Thank you. Bye.
Bye-bye.